Okay, so first we're going to start with the basics. So the three basic shapes that we're looking at in geometry are points, lines, and planes. A point just means exactly what you think. If I have a coordinate point like this. Now, what we need to understand is that a point is a location, maybe on the coordinate plane or whatever, but it has no size shown with a dot. Meaning just because we put point A on there doesn't mean that point A is the size of the dot I drew. And I don't draw a larger dot for an object that might be taking up a larger area. It's just showing a location, for example, a point on the coordinate plane, but it's not showing the size of whatever we're talking about. And our notation is either, what's important is that we use a capital letter with our points. So we can either say point A, okay, so if it's asking you where something is and you go, oh, it's at point A, or if it's just asking you to list the points in a diagram, it's important that we don't just put the letters from now on. So if we're talking about a point, we write point A. Okay, we identify what A is. It's a point. Similar, something we don't really talk about in algebra also is that when we draw a line, just because my pen is a certain thickness doesn't mean that that line is actually that thickness. Okay, so a line is straight. That's important. It has no curves. And no set thickness. And it extends, we do talk about this, infinitely in both directions. And we talk about that in algebra. That's an infinite symbol. Extends infinitely in both directions. Lines are probably where people get the most points off for labeling. Lines or line segments. There's two ways that our lines look. One is we have a line, and on that line, we have some points. So there's an example of a line with some points on it. Notice that the line has arrows on both ends. So hopefully your algebra teacher was also a stickler for this. If you drew a line on the coordinate plane without arrows, that was incorrect. That's just a segment. A line extends in both directions, so it should always have arrows on both ends when we draw a line. Another way lines are sometimes labeled in our diagrams is you can see the line, and it uses a little cursive letter to label it. So there's no distinct points on that line that I just drew. And when that happens, we use the word line to label it, and we say like, well, this is line L. And the lowercase letters for those lines are always in cursive. That's line L. Now here's the trick for the other line, and this is where students make a mistake. When we identify a line in a diagram, we only use 2 points. To have a line, I only need 2 points. So I don't need to identify all the points on that line. And in fact, we should only use 2 points. When we identify lines, segments, rays, anything in a geometry diagram, we identify what we're using. So to show that it's a line, I put a little line symbol above my letters. I'm not drawing a new line, that's just a little symbol. And I could call that line AB. Yeah, C is also on this line, but I know it's extending past A and it's extending past B, so it's still the same line. I'm just saying, well, line AB is one way I could label it. I could call it line AC. That's fine too. But I can't use all three letters. So there's all sorts of ways I could label this line. I could call it AC, and I could flip them around. Goes the same direction, so I can say BA or CA. All four of those are acceptable answers for what the label of that line is. There's another one. What would another way to call that line? What would be another way? BC. Yeah. So I could say this is line BC, or flip it CB. What students do is this. That's line ABC, okay, because it has A, B, and C on it. This is the no-no, okay? To create a point, I only need one dot. A point and a space is one dot. To create a line and a space, I only need 2 points. As long as I have 2 points, I can shoot a line through it, okay? So for our line, we only ever describe a line using 2 points that are on that line. And the order doesn't matter because it's arrows on both ends. So now, continuing on this, a plane, like the coordinate plane that you graph in algebra, is created anytime we have 3 or more points. And it's really not flat on the paper, a plane. It's like extending infinitely forever and ever and ever, this two-dimensional plane. And once I have 3 points, it can extend through those 3 points in all directions, and it creates a plane. The way we draw planes looks like a little rectangle. But we know, like the line, that it continues to go. All those directions, it continues to go in. The coordinate plane doesn't stop just because we only put a graph from -10 to 10. It still goes, okay, in all directions. So sometimes our plane is labeled with like here, cursive letter, and we use the word plane, and we say, well, that's plane M. One way that we label planes that we see. Or there's a few points. X, Y, Z, and I'll go crazy and put another point R on there. Okay, so there's points that live on this plane. When I label a plane, same concept as a line. I only need 2 points to have a line through it. I only need 3 points to create a plane. So we only use 3 points. Now, along with that, we don't use 2 points. So we wouldn't call it like plane X or plane XY. The only time we're going to call it plane X is if X is a cursive letter in the corner like M is. Okay? We use 3 points, and there's no little notation for plane. We always write the word. So I could call it plane XYZ. I could call it, and I won't go through all the examples here, but I could call it plane RXY, and so on. Okay, as long as I have 3 points that are lying on that plane, it's a way that I could label the one I'm talking about. Okay, the plane that contains X, Y, and Z, or the plane that contains R, X, and Y. But I only use 3 points. I didn't define it. A plane is a flat, so it's not 3-dimensional, it's 2-dimensional, 2D surface that extends infinitely in all directions. So the most relatable example you have is the coordinate plane. Goes on and on and on. I could plot the point 1,000 and 3,400. It's a point on the coordinate plane. It's going to keep going. So there's my plane. So we have point line, and plane. Those are the big three. From the line, there are other ways that we can describe, for example, part of a line. So if we're shown part of a line, it's a line segment. And it's going to has two endpoints. If I'm showing you a part of something, it's not extending infinitely. I'm saying, I want to look from this point to that point. I want to look at this segment of the line. And we would label those points. So we would say, well, I only want to look from point M to point N. And so how I would label that with a segment on top, little notation segment. It's not like a big segment. It doesn't have points on it. So just notice the difference is that this little mini line notation has arrows. So it's lining the segment MN. But I don't draw in like the points here. I'm not redrawing the diagram. It's just notation. Segment MN. Is it the same length if I go from N to N as it is if I go from N to M?
Yes.
Yeah, it's the same both ways. So I could either call it MN or I could call it NM. Okay. And then we have our rays. Now, a ray is also a portion of a line. But this portion has one endpoint. The other direction. We can't write it first. It's a ray of sunshine. It starts on the sun, that's its endpoint, and it's shooting out, extending infinitely. If you were to actually draw what's happening there, that's shooting out of light. Okay, a ray has an endpoint and then shoots out in the other direction and extends infinitely. And when we're given a ray, we're going to be given a point that it's going through. So it's starting here, goes through this point, and then keeps going. And so I'll call that ray AB. Here's the other big points loser on quizzes is rays. When I label a ray, the order matters because my label always goes, the ray always goes from left to right on my page, the little marker on top. So I have my lines, I have my segment, and here's the ray symbol. So it goes endpoint arrow, I need to go endpoint to the side that has the arrow. I have to go, that's ray AB. It is not ray BA. Ray BA, the letters would be in different spots. The B would be the endpoint and the A would be the other, would be over here. Okay, we cannot do this. Not ray DA. Okay, so with our rays, order matters. Okay, it has to go endpoint through arrow, endpoint to arrow. Okay. Collinear points. Co. What does it mean? Like I'm coexisting. Co-parenting. What does that mean when co is in front of it?
Oh, for this, I think it's like you put another point.
Yeah, the points are are on the same, what do you think? Line, yeah, they're sharing a line. Okay, they're doing it, they're all on it together. Okay, so here's a line. Let me give us our definition first. So points on the same line. I'm going to put some points in here. L, M, N, put P over here, K up there. I drew 5 points. But only 4 of those 5 points can be called collinear. Which points are collinear? L, M, N, and P are collinear. Okay, they all live on the same line. K, although it's a point, it's not collinear with L, M, N, and P. It's not a part of their party. No, I could have put it P, M, L, N are collinear. No matter. What does matter is that if you're asked this question, that you don't just write L, M, N, P without the point indicating that you're talking about points on that line. Geometry is very specific in that way. And so if I can have collinear points, I can also have coplanar points. Now here's the trickiest diagram yet. So draw yourself a plane. Let's just start there. And what do you think, what would you guess coplanar points mean? Points that are what? Instead of being on the same line, they would be on the same plane. Yeah. So points on the same plane. Now it hurts your head a little bit to think about these. Now they're two-dimensional, so they're extending in all directions, but they're not extending like up and down, okay? So you're gonna see planes that crisscross, that cross each other, okay, going different directions. Or you might see a line that starts above a plane, hits a plane at a point, we'll call it point B, and then extends out underneath that plane. So when that line hits at point B, that's the only point that the line and the plane are actually touching each other. The line is living on a different plane that's going in a different direction. Okay, so it's hitting this plane at point B, and I'll put point A here. Okay, so I have point B and A. And I'm going to put C and D on the plane that the line just hit. And so which points are coplanar there? B and A are coplanar if we had a different plane drawn in. But which points, how about this? Which points are coplanar on plane L? B, C, and D. Yeah, because technically there is, even if we don't draw it, there's some sort of two-dimensional field that line's living on. Didn't draw it in. You'll see it in a few notes. We have planes crossing each other. But if I'm talking specifically about this plane that I have, A is outside of it. But point B, C, and D, in any order would be fine, are coplanar. And we also sometimes are asked to just show, like, pick some non-coplanar points. So points that are non-coplanar, I could say, well, point C and point A are non-coplanar, which just means they don't live on the same plane. They live on different planes. Okay? C and A. C is on this plane. A is not.
Yeah, no, but you just said C and A are non-coplanar.
Are non-coplanar, not coplanar. B, C, and D are coplanar. B, C, and D. But C and A are not coplanar. Did it get there or not? Okay. Okay. So then what we're going to be doing tomorrow, you'll see that there's some labeling here. And my hope is that everyone signs on, because I'd really like to do this with the whole class. So so we're all on the same page. So we're gonna stop there today. We're a little bit early. So that we can pick